Okay. Till now, what we were doing? Anyone? What
Mean
did
value
we do
for
yesterday?
binomial distribution.
Huh? What did we do?
Mean, mean value for binomial distribution.
Okay.
Then limits of binomial distribution.
Okay.
There are two types of distribution.
Okay.
One is Poisson distribution and another one is Gaussian distribution.
Okay. Basically, what we did yesterday was we found the mean of a binomial distribution. For binomial distribution, we got the mean. After that, we consider two different limits. In these two limits, the binomial distribution will basically become, one is Poisson's and another one is
Gaussian.
Gaussian distribution. So what we are going to do today is, till now I think we have done all the preliminaries for the statistical mechanics. I think we have done everything, starting from probability, then after joint probability, something exclusive, inclusive, and this kind of thing, and probability distribution, probability density, so on and so forth. So how do we connect this with what? Thermodynamics. Clear? So today we are going to again talk about micro and macrostate. Microstate and macrostate. Do you know what does this micro and macrostate means? Do you know? I think previously also, I think we have done what is microstate and what is macrostate. But we'll do it today in a slightly different manner. Suppose you have a four distinguishable particle. Distinguishable particle. What does distinguishable means? What does distinguishable means?
So
What
to
does distinguish?
It can be differentiable, sir.
Okay. It can be what?
We can differentiate, sir.
Oh, very good. Exactly. We can differentiate. That is called distinguishable.
Connection and restart.
What, Sanjay?
So I'll restart, sir.
Okay. Basically, distinguishable particles are those which we can distinguish, and indistinguishable are basically what which we cannot distinguish. Basically, I will give you an example. Let's have a system with one red bulb and one blue bulb. Clear? And another system with both blue bulbs. Now here you can distinguish between each and every particle. Clear?
Yes, sir.
Here you cannot distinguish it. This kind of things are called what? Indistinguishable, and these are distinguishable. Clear?
Yes, sir.
So after this, what we can do? How can we distribute them? Clear? Now suppose we have how many compartments? Into two compartments. Clear? These four particles into two compartments. What does this mean? Our two compartments are, let's say we have a box and which is distributed in this manner. Let's consider two-dimensional. It will be easier for you to. And we have two compartments, 1 and 2. Clear? Of equal size. Clear, Indira? Clear, Abhishek? Everyone
Yes,
clear? I think it's clear. So as the particles are distinguishable, let's call them A,
Sir, once more.
B, C, D. Clear? Now we have a compartment which has equal to, clear, two compartment of a box. And we want to place a particle in this box. Clear? Sanjeev? As the particles are distinguishable, what we can do? We can write them as A, B, C, D to say that A is red ball, B is blue ball, black ball, green ball, in that manner.
Yes, sir.
After this, what we can do is, on how many ways can the particle be arranged over here? One obvious choice is what? Because both will have equal probability. Can you tell how much the probability will be for ending up in one of the boxes?
1/4.
No. How we used to do, consider the volume divided by total volume of particle V by V. Now leave it for a timing, it's not needed. Now we are just considering what? Micro and macro state. Now there are how many compartments are there?
2.
There are two compartments. Exactly. Let's consider this as compartment 1 and compartment 2. Or let's consider this as compartment 1 and compartment 2. Is it clear?
Yes, sir.
Yes, sir.
And on top of this, we can write distribution. Okay, first what we can have, first scenario is a particle A will be here and the remaining B, C, D could be here. So we'll have, or the first scenario is nothing is sitting over here and all the particles are sitting in compartment 2. So that we can write in compartment 1, how many particles do we have? 0.
0.
And over here, how many particles do we have? 4.
4.
Similarly, in the second scenario, what we can have? Distribution 1, this is, let's say, distribution 2. What we can have? 1 particle over here, 3 particles over here. Clear? Is it okay, this one? For distribution 3, what we can have? 2 particle over here, 2 particle over here. Clear?
Okay, sir.
For distribution 4, what we can have? If you draw in this manner, A will be here, B, C, D will be here. This is 1 particle in compartment 1 and 3 particles in compartment 0.
2.
A2, yes, sorry.
2.
And finally, in distribution 5, what we can have?
0.
Yes, sorry, this one should be 3 and 1, no? 3
Okay.
and 1. So this should be 4 and 0. Clear?
Yes, sir.
So these are the kind of distribution which can occur in this box. Now what we can do? How many distribution now do we have?
5.
Okay, 5 number of distribution. Which is given by what? 0 and 4. Clear? 1 and
1 and 3. 2, 2.
2, 2.
3, 1.
3, 1.
4, 0.
4, 0. Clear? Now each particle will have equal probability, so that's why it's sitting in this manner. Clear? For timing, no, this is just the distribution. This is how it will be get distributed. Clear?
Yes, sir.
Yes, sir.
No. This is basically called here macrostate. Macro. Clear?
Yes, sir.
This is
Yes,
called
sir.
here macrostate. Now, what is a microstate? As the particles are distinguishable, what you can have is, as the particles are what? Distinguishable. What we can have? Let's say we have 0 particles over here or A particle over here. Clear? And we have B, C, D. But it can occur in this manner. If you check B, C, D, D, B, C, and after that C, D. Are you understanding this?
Yes, sir.
After that, which combination is possible?
BCD.
B, D, C.
Yes, sir.
B, D, C. After that, C, D, B. Yeah, I think that is done. Now there are four more possible ways in which this B, C, D can be arranged. Clear?
Yes, sir.
Now, in each compartment, how this will look? This is in compartment 1. Let's call it. Clear? Now this is possible arrangement, how it can be arranged. This is your compartment 2, and this is your number of microstate. Let's call it microstate, which is given by W. Clear?
Yes,
For timing, just count it. Now for the first arrangement, what was this was a macrostate. No, macrostate. What was a macrostate? First 0 and 4. Clear? So on the compartment, it will be 0 particle over here, and on the other, it will be A, B, C, D. Clear? Is it clear?
Yes, sir.
Yes, sir.
So on the second, we have 1 and 3.
So
Is it-
there should be 4 compartments, no, right now, sir?
No, we are just considering these 2 boxes, which are 2 compartment 1 and 2. Still, there are just 2 compartments.
Okay, sir.
Clear?
Yes, sir.
So this will be what? On how many ways can this will be one particle? Either particle A may be here and B, C, D will be here. Yeah. Either particle B will be here and what will be here? C,
And
D.
C, D, A.
Clear. C could be here and what? D, A, B could be here.
Yes, sir.
And D could be here, A, B, C could be here. Now is it clear?
Yes, sir.
Yes, sir.
Now this is even here what it can be distributed in this manner. For a given macrostate also there are what? There are different kind of distribution which can occur. Clear? And this kind of states are basically called what here? Microstate. Clear? For a given macrostate it can have different microstate. Now let's count the number of microstate. How many microstate can we have? 1, 2, 3, 4. How many microstate do we have here? 4. How many microstate do we have here? Only 1. Is it clear why we have only 1? Because no particle is on your left box, all the particles is in your right box.
Yes, sir.
Yes, sir.
Is this clear or not? I will just tell you once more if it's not.
Clear,
Yes.
sir.
It's clear, no? Or
Yes,
should I
sir.
tell it? Okay, then it's
Sir,
fine.
briefly, sir.
What else? Because let's consider this scenario first. There was no particle sitting over here. Let's consider this. There was no particle sitting over here. Now A, B, C, D, all the particle will be over here. This is the only possible arrangement. Clear? Because it's already over here. Now distribution between 2 compartments can be done only if the particles are in both the boxes. Clear?
Yes, sir.
It's like you have 4 balls, let's say A, B, C, D. First, you didn't pick any ball. Clear?
0.
That is 0.
Yes, sir.
Now, second is picking one ball from which this 4. You can, at that time, you can either pick A You can either pick B, C, D. Clear? Is it clear?
Yes,
Oh.
sir.
Okay, now if you check this, how it will look. Now the number of microstate in this manner, you can keep on going. For AB, how many do we have? 6, so on and so forth. But if you check it closely, what you can do get is the macrostate has the information of do you remember this formula where we had Indira, Abhishek, anyone? Do you remember where did you have this?
Yes, sir.
Where?
Poisson equation.
Yeah, in Poisson's equation also we have. Apart from that, in binomial distribution, did we have probability of finding n?
Yes, sir.
P to the
Yes, sir.
power, what it was? P to the power n minus q to the
N
power.
minus n minus n.
Okay. If you just consider this piece, okay? If you just consider this piece, let's put it in this manner. For the first case, for the with 0 and 4. Yeah. 0 and 4, let's consider only the in between. So I'm writing with different color, okay? So n factorial was number of particles was 4. 4 factorial divided by what was 0 we have to pick. And it was 4 minus 0 factorial. So basically it will be what? 4 factorial divided by 4 factorial. This is basically 1. This is what? Number of microstate. Now let's consider second one. What was the second arrangement? 1 and 3. Clear? Now to find n, you have to add this both. That will give you a total number of particles. Clear? Number of particle in your left box plus total number of. So it's again 4. So divided by how many we are choosing? 1.
1.
So 4 minus 1 will give you what?
3.
4 factorial divided by 3 factorial. What we can write? 4 into 3 factorial divided by 3 factorial will give you what? 4. This is the number of ways in which one can arrange this. So this formula, what we can write? We can slightly modify this formula for the binomial and we can write probability of getting n is W. W of n you can write. Clear?
So 3 factorial, how it came, sir?
3
factorial, sir.
Where?
Above, sir.
Here.
Yes, sir.
What? For 3 factorial. For 3 factorial also you will get. You can choose either one of the state. Actually, it doesn't matter. For both, it will give you same. Clear?
Yes, sir.
Just try it. Just try it. It will be what? 4 factorial will be on top. It will be 3 factorial. And it will be how much? 4 minus 1 factorial. How much you get? 4 factorial divided by 3 factorial. Again, you will end up with 4. Clear?
Yes, sir.
But you have to choose only one number from this microstate. Clear?
Yes, sir.
Is it clear?
Choose anyone, no, sir?
Anyone. Now, this means different thing. If you choose 1, it means the number of particle in your left compartment is 1. Clear? And on your right compartment will be 3. Clear?
Yes, sir.
And if you choose 3, that will be 3 particle on your left compartment and 1 particle on your right compartment. Just think of that in this manner. Clear?
Yes, sir. Got it, sir.
Okay.
Yes, sir.
For 0 and 4, what it will be? 0 on your left compartment, 4 on your right compartment. Clear?
Yes, sir.
Yes.
Now, if you choose 4 and 0, it will be 4 on your left, 0 on your right. Clear?
Yes, sir.
So the probability distribution can be write in this manner. So basically, W of n will give you what? Number of microstate. I think it's clear till here. Is it clear why did we write this? W. Basically, W was what? N factorial divided by n factorial, n minus n factorial. So this is also called here what? A slightly different name. Let's call it. What do you call? Let's call. What shall we call? It's actually called what? Thermodynamic probability. Actually, this is basically what? Basically, this is a distribution kind of thing, but this is basically a combination. So let's call it, actually we cannot go away with, or this is basically the number of microstate. Clear? Now number of, sometimes you use the what? W, or sometimes you also use omega. Clear? So usually we use omega for the number of microstate. So we will use W or omega. Let's use omega itself because omega is standard. Clear? Number of microstate can be either written into W or
omega.
Or omega. Clear? This is number of microstate.
Microstate.
So which one is bigger, microstate or macrostate?
Micro.
Yeah, microstate is bigger because the number of states are more. Here you had only a single state. For that, how many additional states you did have? 1, 2, 3, 4.
4.
Yeah.
Yes, sir.
I think it's done. Microstate, macrostate. Now let's consider this one. Just wait, okay. I'll just check where the recording is going.